Okay, so this video is for section 6.4, and in this we're going to talk about the confidence intervals for your variance and standard deviation. So we have a point estimate for our population variance. So our population variance, which is represented by sigma squared, and the point estimate for that is going to be S squared. And then we have a point estimate for your population standard deviation, and that is going to be S. The most unbiased estimate for your population variance is going to be your sample variance. Okay, so we are going to talk about something called the chi-square distribution. You might hear it chi or chi, it just depends on the person. So what we're going to need is we're going to need this formula right here. Whoa. All right, that was pretty good. All right, it's just a little wavy. It's wanting it to be summertime. So we're going to use this formula to construct our confidence interval for both the variance and standard deviation. We need a sample of at least one, obviously, otherwise this would just give you 0, and that would be not helpful. And we still have to have a normal distribution. So let's talk about a few different properties that we need to have. So the first thing to keep in note that all of your chi-square values are going to be greater than or equal to 0. The chi-square distribution is actually a family of curves, and each of the curves is determined by the degrees of freedom that you have. And remember, to get your degrees of freedom, we're going to do 1 subtracted from our sample. And just like before, the area under the curve always has to equal 1. And so one of the things that you're going to notice is as our sample size increases, our degrees of freedom increase, the curve is going to be more representative of a normal distribution. Okay. So the other thing to note here is that your chi-square distribution is going to be positively skewed. So you'll notice most of the data is on the left here. Okay. All right, so let's kick this off with an example. We are trying to find both critical values for a 95% confidence interval when your sample size is 18. Okay, so the first thing that I need you to note is that your sample size is 18. So that's n equals 18. Ooh, I just got a new pen, so that's why my writing is a little crazy. My degrees of freedom is going to be 1 less than that. Okay. So what we're going to do to figure out my right and my left critical value, you're going to take that 95% confidence and you're going to subtract it and add it to 1 and then divide those values by 2. And we're doing this so that we can get the tails, okay? So let's see. So the right value equals 1 minus 0.95 divided by 2. That is a 2. This is a 9. To make it a little bit bigger. Okay. And if I do that, I am going to get 0.025. And then let's go ahead and do the other one before I turn to my book to get these values. So just like our t-distribution, we have a table of values that we're going to reference for this. So the left bound you're going to get by doing plus 0.95. All right, so that one is going to give you all right, so now what you're going to do is you are going to look in your book for these two values. Okay, so it is on page A19. So page A19. So what you're going to do when you're referencing this is you are going to look across the top to get the confidence level. So in this case, 0.025 and 0.95, and you're going to go down to match your degrees of freedom, which in this case is 17. Okay, so if you're using the chart on page 18, so I'm going to just use the text real quick. Page A19. Okay, so if I look at page A19 for 0.025, I'm going to get, ooh, I'm still on text. There we go. Oop. Okay, so this value is 30.191, and 0.975 is going to give me 7.564. Okay, so those are my two critical values. All right, so let's do another one, and I actually want you to pause the video and you try this one. Okay, so hopefully you have tried this question. All right, so first I want you to notice that your sample size is 30, which is telling me that n is 30. And that means my degrees of freedom is 29. Okay, so I am going to use my 90% confidence to calculate both values. Okay, so first, we're going to do 1 subtract. Ooh, 90. Whoop. This is a 9. Whoop. All right, and if we do that, we will get 0.0. Whoop, that's bad. Okay, there we go. 0.05. And then we're going to do the same thing, but we're going to, got too many things going on my computer. It's thinking. Okay, we're not printing. All right, here we go. So. Okay. 1 plus. All right, so if I do that, I'm going to get 0.95. All right, and then I'm going to look back to page A19, and I'm going to look over at the top for 0.05, and then I'm going to go down to 29 for my degrees of freedom. And if I do that, I will get, for 0.05, 42.557. And for 0.95, I got 17.708. Okay, so now what we can do with that is we can actually use those critical values to create our confidence intervals. So when you're looking at this formula, you'll notice the only difference between these two is the fact that your variance is squared, and to get the standard deviation, you just take the square root. Okay, so let's run through the steps that we need. So first, you always need to make sure that your population has a normal distribution. Then you're going to figure out your degrees of freedom using this formula here. Find your variance. Sometimes if they give you data, you're actually going to have to type this into the list feature of your calculator and calculate it. Find your critical values using your table, and remember that was on page A19. And then you're going to find your right and left endpoints. And you'll notice, again, the only difference between these two formulas is that we're taking the square root here to get our standard deviation. Okay, so let's go ahead and put this into practice. So we are randomly selecting 30 samples of allergy medicine. The sample standard deviation is 1.2 milligrams. Okay, so let's write this down. We have N equals 30, which means my degrees of freedom is 29. S is 1.20. Assuming the weights are normally distributed, phone is going crazy. Boop. Assuming these are normally distributed, construct a 99% confidence interval. Okay, so the first thing that I have to do is I have to deal with this 99% confidence to find my two critical values, okay? So, all right, here we go. Getting better at writing as this video is going on. It's an interesting thing because the screen that I'm writing on is completely blank. So it's taken a little bit to get used to it. It's pretty cool though. It's up in my teacher game here. All right, so if you do that, you're gonna get 0.005. Let's do the other one. Left one. And this is going to give me 0.995. All right, so now I'm going to check with page A19. So I'm going to go over to 0.05, go down to 29, and if I do that, I'm going to get 52.336. And 0.995 is going to give me 13.121. Okay, so now I'm going to plug into my formula. So my formula is right here. So I'm going to do my degrees of freedom times my standard deviation squared divided by my two critical values. Okay, and that's going to give me the left and right bound for my population variance. Okay, so let's go ahead and do that. Okay, so my degrees of freedom is 29 times 1.2 squared, all divided by 52.336. And that is going to give me 0.80. I'm going to do the same thing, except this next time I'm going to divide by my other critical value. Which is 3.18. Okay, so now that is my answer for my variance. It's 0.80 and 3.18. And then to get my standard deviation, I'm just going to take the square root of each of those numbers. So the square root of 0.80 is 0.89. And 3.18 square root is 1.78. Okay, so we're going to write our summarizing sentence now. And I'm going to use the keyboard to type this because otherwise we'll be here for a long time. Okay. Click that extend the page button. Okay, so make this a teeny tiny bit smaller because it's a little too big and we're going to not use this font. I'm going to use just some more simple font if I can find one. Here. Okay, all right. I need just normal font. Okay, here we go. This is good. All right, so with 99% confidence, the population variance is between 0.80 and 3.18, and the population standard deviation is between 0.89 and 1.78. Okay, so I got another example for you. So this next example, they just gave us a list of values. So what you would actually need to do is you need to plug these values into your calculator. So remember, the steps for that are you're going to use the list feature and you're going to type in all of this data, and then you're going to go over to calculate, and it's 1 vars. And then that's going to give you your sample standard deviation, which is 0.0321. Okay, so we have 15 bottles of cough syrup, so that's my N. Which means my degrees of freedom is how much? Yeah, 14. Okay, so now we're going to use our 90% confidence interval to first find our critical values. Okay, so jump down here, beep. Okay, so first we're gonna do 1 minus 0.90 divided by 2, and that is gonna give me 0.05. And then I'm also going to do 1 plus 0.90 divided by 2 equals 0.95. All right, and then I'm going to look at my chart, and I'm going to go over to 0.05 and 0.95 respectively, and then go down to 14 for my degrees of freedom. And that is going to give me 23.685 and 6.571. Okay, so now what we're going to do is we're going to take each of those numbers and we're going to divide them. We're going to divide our degrees of freedom times our standard deviation squared. Okay, so degrees of freedom was 14 times 0. I messed up. I tried to save it, but it looks too much like a 3 and I don't want to confuse people. Okay, there you go. Squared, all divided by. One time we're going to do the 23.685. So that one is going to give me 6.09 times 10 to the 4th. Negative 4th, I should say. And then I'm going to do the exact same thing, except I'm going to divide by the other number. So 6.571. And that is going to give me 0.00220. Okay. So, give myself a little bit more room. Okay. So what that tells me is my population variance, and then to get my standard deviation, what am I going to do? I'm going to take the square root. So the square root of 6.09 times 10 to the negative 4th is going to be 0.0247. And then the square root of 0.0020 is going to be 0.04685. Okay, so really, really small numbers. So let's write our summarizing sentence now. Okay, so with 90% confidence, you can say that the population variance is between 0.000609 and 0.00220, and the population standard deviation is between 0.0247 and 0.04685. Okay. All right, we got one more example we're going to do. Okay. So we have a magazine is including a report on the prices of digital cameras. The article says that 11 randomly selected digital cameras have a sample standard deviation of $109. The prices are normally distributed. Construct an 80% confidence interval for the population variance and standard deviation. All right, here we go. So first, we know that we have n equals 11, which means degrees of freedom is 10. My sample standard deviation is $109. Okay, so let's go ahead and find our critical values. So we are going to do 1 minus 0.80 divided by 2. And that is going to give me 0.1. And then we're going to do 1 plus 0.80 divided by 2. And that is going to give me 0.9. All right, so then we're going to look at page A19. And page A19 is going to give us the value of 4.865 and 15.987. All right, so now we're going to plug those in. So we're going to do degrees of freedom 10 times sample standard deviation squared divided by 4.865. And I'm going to get 24,400. 38. I'm going to do the same thing. Kind of right sideways. And this is going to give me 7,431.66. Okay, so let's go ahead and write that. So remember, your smaller number is always going to go on the left side. And then you're going to go ahead and take the square root of each of these. So the square root of 7,000 is 86.21. Oop, I already wrote that. Oop. And the square root of 24,000 is 156.27. All right, so then the only thing left is we're going to write our sentence. Okay. With 80% confidence, the population variance is between 7,431.66 and I should use dollar signs. 421.8. Put those dollar signs in there. It's got to be official. Oop. And the population standard deviation is between 86.21 and 156.27. All right.